Alright, so let's talk about lines and systems of equations. It should be noted that this amounts to an algebra video. Like, this is the same kind of video I could give in the, like, Algebra 2 class. So we're going to start from that perspective, and then we're going to move forward into some really, really abstract stuff. But today should be stuff that you've seen before. Okay? So let me write down a couple systems of equations here. Say we have this system y minus x is 2, and minus 2y plus 2x is negative 4. So, can you guys tell me something about this? Like, what do you guys know about something like this? Say it right now.
They're scalar multiples of each other?
Yeah. That's weird, right?
So they're parallel.
You guys see that?
Oh.
Yeah, they're actually the same equation. Okay. Yeah, so, like, right here, they're really kind of geometrically, there's really only one equation here geometrically, right? You see that? Okay, so when there's really one equation, I just said the word geometrically, but what does it mean geometrically? Like, what are these equations geometrically? Yeah, these are lines, right? So this is the case where there's the line y minus x equals 2, right? I'm not sure that it necessarily, let's see. Yeah, should have positive slope. It looks a little flatter than it should. But it's that line, and then what's the other equation? Yeah, it's another copy of the same line, right? So when I ask for how many solutions does this have? Yeah, this is the case where there are infinitely many solutions. This is what drives Algebra 2 students nuts, right? Like, they try to eliminate and it just seems like nothing's going anywhere. You guys remember that step? Okay. So that's the infinitely many solutions case. Alright. What if we had y plus x is 0 and, oh, that still has minus 3y plus 2x is 0. Tell me about these guys. Okay. How do you figure that out? How do you find where they meet? You guys have techniques for this? Like,
rearrange it so it's like the formula for algebra requires us to be
okay.
or like set them equal to each other.
Yeah, like there's a couple options, right? You guys know a bunch of options for solving things like this, right? So just kind of off over here, I want some options for solving. Like, I can solve a system several ways. What are the ways you guys know? Do you guys know the names? I'm thinking of 3 specific names.
Elimination.
Okay, one of them is ref-ish. So I'm going to call that one the augment matrix method. I guess I'll write augment and ref because... Yeah, so we're going to dig into this one pretty hard in linear algebra because linear algebra is kind of matrix theory. So this is going to be the one that we kind of go after. But there were 2 more. Perfect. Substitutions 1 and elimination is the other. Okay, so looking at this thing, this little system, what would substitution look like here?
solving for one of the variables and then plugging whatever that variable is into the other equation.
Perfect. So I might take this equation and say, okay, that equation means that y equals negative x. And then I can plug that in here. You might notice that these two lines meet at the origin. You guys see that? Like, that's a pretty obvious solution to both of them. You might also multiply this equation through by 3 and add the two equations together. Right? That's the elimination option. So, in a kind of algebra context, we teach substitution, we teach elimination. I'm going to spend a little bit more time going into augment and ref today, but that's going to be really where this course is at. That said, don't forget you have those other two options. Sometimes they're faster. Like, in this one, they're faster. Like, by the time you get this entered in the calculator, somebody will have been like, dude, they meet at 0. Like, check, done. How many solutions are there to this? So this is 2 lines, right? Something like that. And there's one unique solution, and that is the meeting point of these 2 lines. This is kind of the case that you get when you pull lines at random out of the world. You guys see that? Like if I think about the way these equations are kind of written out, there are really 6 numbers here. You guys see that? If I pull 6 numbers at random out of the universe, they're gonna be in this case. You guys see that? It's not impossible that I could have like this kind of scalar multiple problem, but it's not likely. So I said there were 3 cases. What's the 3rd case? You guys remember? Say again? No solution. How do you get to no solution? Okay, when the lines are parallel and not intersecting. Right, like this. So really, to this one I should add 2 non-parallel lines. What's that? Yeah, so also keep in mind that this is in the 2-dimensional case. You guys see that? People who have had kind of a 3-dimensional thought process invested in them can maybe tell me of an option in 3-dimensional space. But I'm not going to do that right now. So let's ignore it. So how do I get these kind of no solution case? Right? It's going to be 2 distinct parallel lines. Right? And how the hell do you get that out of equations? You guys make me some equations?
They just need the same slope.
Okay, they need the same slope,
Different intercepts.
but different intercepts. What do you got, Lee?
So something like y equals x and y equals 2x.
Low. So
X plus 2. That's what I think.
good, yeah. So something like y equals x is 1, and the other one might be y is x plus something. Cool. Perfect. You guys, everybody's with me on the geometry of 2 dimensions here? Okay, cool. So this is going to be our starting thought process today. You guys are all super comfy with this? Any questions on this before I move to augment and ref?